This week we're going to learn about integration technique that is called the substitution. We're going to use the substitution in order to determine or find the integrals that are more complicated than the simple integrals that we have been studying. Our goal is to evaluate integration using the substitution method. We're going to use the substitution method usually when we are seeing an expression that we did not learn how to integrate before. For example, if you want to evaluate the integration of 5x squared plus 2 all to the fifth power times 10x dx, we don't know how to solve that using the old techniques, the power rule and etc. We resort to a new technique. Before we do the new technique, let me point out some observations here. You will notice that if you look at the integrand, you will see that the integrand 5x squared plus 2 all to the fifth times 10x, this is basically the chain rule, because I have the derivative of what's inside the parentheses outside, which is 10x here. So this is basically the chain rule. If I want to find the integration of this, then I'm going to think about what is the antiderivative of 5x squared plus 2 to the fifth power, and then here is the derivative of what's inside those parentheses. So I will think of 5x squared plus 2 to the sixth power. But if you differentiate this, you will get an extra 6. So what we do, we're going to divide both sides by 6, and we will say, well, the integration of the given integrand is basically 1 over 6, the antiderivative of that plus c. Now, this seems complicated, but we're not going to use that method, which is just basically trial and error to figure that out. I just wanted to point out that we are doing actually the chain rule in reverse. So here are the steps that we're going to follow in order to find this type of derivative. First thing, we're going to look at the inner function, and we're going to say that the inner function is equal to an amount. Let's say it's u. Then we're going to differentiate u with respect to x. So we have to compute du over dx. If you do that, you're going to get 10x. Now, I only want du. I don't want du over dx because I want to substitute in here. So what I will do, I'm going to multiply across. So if we multiply across, we will get du equals 10x dx. Now, we have this amount. We made it equal to u, so we have to substitute this with u. And if you notice, this amount we got it when we found the derivative of that u, which is that amount, it's equal to du. So if we rewrite this integral in terms of u, we will get the integral of u to the fifth du. Now we know how to integrate that because we can use the power rule in this case. So if you use the power rule to integrate, you will get u to the sixth over 6 plus c. We know that u, we assumed from the beginning that u is equal to 5x squared plus 2. So we can replace u with its value. We could say that the integral of 5x squared plus 2 to the fifth, 10x dx, is basically 5x squared plus 2 to the sixth power over 6 plus c. And that will be the final answer. So we basically took this complicated integral and we assumed the inner function is equal to u, and then we substituted everything with u. That simplified the integral for us. Now we can integrate that integral, and then don't forget to substitute u back with its value, so you have your answer in terms of x. The procedure. First, we're going to choose a substitution. U equals g of x. Usually, it is best to choose the inner part of a composition function, such as a quantity raised to a power, or the exponent of an exponential function, or the argument of a log function, or the denominator of a rational function, or what's under the square root. Usually those are good choices for u. Then we're going to compute du, which is basically the derivative of g of x times dx. Remember how I did that? I said we find du over dx, which is the derivative of g of x, and then I want du by itself, so I'm going to cross multiply, and that will lead to du is equal to g prime of x dx. Rewrite the integral in terms of the variable u, and then find the results of the integral in terms of u. Replace u by g of x again to obtain the antiderivative in terms of x, and then you can finally check your answer by differentiating to make sure that you got the integration right. Let's try that. The first example, we want to find the integration of x cubed minus 9 all to the 5th times 3x squared. Now I notice here that I have parentheses raised to a power, so I'm going to assume that u is what's inside those parentheses, which is x cubed minus 9. This is u. Now I need to find du, so I'm going to differentiate. I will have du is equal to 3x squared minus 0 dx. Now I will need to replace everything in this function. Luckily it's straightforward, so this amount gets replaced with u, and I have 3x squared dx here is equal to du, so I'm going to replace it with du. So what I will get something like integral of u to the 5th du. Now that's an easy integration to do. We use just the power rule, so I'm going to use the power rule. I have u to the 6th power over the new exponent or new power plus c. So that will be the final answer in terms of u. I began my question with integration that is in terms of x, so I will need the antiderivative to be in terms of x as well. I know the value of u, which is x cubed minus 9. We assumed that, so I'm going to replace u back with its value, x cubed minus 9 to the 6th power over 6 plus c. So here is another example. I need the integration of x to the 4th plus 2 to the 4th power times x cubed dx. Again, I have parentheses here raised to the 4th power, so I'm going to say that u is equal to x to the 4th plus 2. So I'm assuming that u is the amount inside. Now I will need to find du. So I'm going to find the derivative. Du is equal to 4x to the 3rd power plus 0 dx. So now let's do the substitution. We have u, but we have x cubed dx. We don't have 4x cubed dx. So what we do, we can divide both sides by 4. So we have x cubed dx, which is exactly that amount, is equal to du over 4. Now let's rewrite that in terms of u. So we have the integration of u to the 4th power times du over 4. Here is 1/4 that I can kick out of the integration. So I will have 1/4 integration of u to the 4th du. Again, this integration, I can use the power rule to integrate. So this is equal to 1/4 u to the 5th power over 5 plus c. So this is equal to u to the 5th power over 20 plus c. Now, all I have to do is to replace u with the original value of u that we assumed from the beginning. So the antiderivative is going to be x to the 4th plus 2 all to the 5th power divided by 20 plus c, and that is the final answer to that question. I hope this video helped you understand the basics of using the substitution method. I'll see you in a different video.